Hi, welcome back. In this video, we're going to talk about how do you divide rational functions using long division as a method. Now, in the next video, I will show you a different approach. So if this method doesn't resonate with you, you're welcome to watch my next video, which is going to be called synthetic division. So we're going to be dividing polynomials, right? We're going to be dividing some sort of function by another function. And to do that, why don't we review first, how do we divide just numbers in general using long division? Like, let's say that we're dividing 745 divided by 4. If you go back to your elementary days, we want to think about 4 times a number goes into 7. So 4 goes into 7 one time. And we multiply, right? 1 times 4 is 4. And then we subtract. That gives me 3. Then you bring down the next number. 4 times a number goes into 34, which is 8. So we multiply. 4 times 8 is 32. We subtract. And we bring down the next term. Right? We multiply. 4 times 6 is 24. We subtract. And then there's nothing else to bring down. So this becomes my remainder. Now there's a lot of ways of writing the remainder. We could say 4 goes into 745 186 times. Remainder 1. That's probably one of the ways that you learned it. We're going to be using this notation, 186 plus the remainder over the original problem. So 1 over 4 is 0.25, so 186.25. If I were to break down the concepts here, this is what I'm going to be doing. I'm going to multiply first, right? 1 times 4 is 4. Then we subtracted. Once we subtract, we bring down the next term. Bring down. Multiply, subtract, and then bring down. This is the 3 steps that we're doing constantly, right? And we're going to use these 3 steps when you're dividing functions as well. Dividing polynomials. So let's do a few examples. My goal is to do 2 or 3 examples, and let's give it a go. So here we're dividing a quadratic by a linear expression, right? The numerator will go inside, so when you're dividing, you're going to write this as x squared plus 5x plus 3. And we're going to divide it by x plus 6. That goes on the outside. Now, if you remember, we're going to first start by multiplying, subtracting, and bringing down the next term. That's the steps that we're going to be following. But we're only going to focus on the first term. Yeah? X times something is x squared, and that's x times x. So we're going to multiply x times both of these terms. X times x is x squared. X times 6 is 6x. And it's a positive 6x, we can put a plus there. Now, after multiplying, we subtract the terms. So we're going to subtract these two. Notice how the x squares cancel. And now we have 5 minus 6, which is negative 1x. We've multiplied, we've subtracted. Now we bring down the next term. And we repeat the process. X times something will give me negative 1x. Yeah, x times negative 1. So we're going to multiply negative 1 times x and negative 1 times 6. Negative 1 times x is negative 1x. And negative 1 times 6 is negative 6. After multiplication, I subtract. Anything minus itself cancels to 0. 3 minus negative 6 turns into plus 6. And since there's nothing to bring down, this becomes my remainder. We're going to write this solution as x minus 1 plus 9 over the original problem, x plus 6. So when you're dividing these two, we're going to say x minus 1, x plus 6 will go this many times into this polynomial. Now, long division, synthetic division, what we're going to do in the next video, right? The result here has a meaning. We're dealing with like slants, right? Whenever the numerator is bigger than the denominator, we're dividing in the graphing components of our unit, of graphing a rational function, like something like this. If we're trying to graph it, this becomes the slant. I would go to -1. That's my y-intercept, right? Y equals mx plus b. It starts at -1. And then the slope, which is up here, is just 1 over 1. So you would go up 1 over 1, up 1 over 1, up 1 over 1, and it would create a slant like this. The x minus 1 would be my slant. So the meaning of the division of these two will take on its own, depending if we're graphing, if we're applying this to other properties, if you're trying to find the factors. There's a lot of different things we can look at. But for now, can we divide two polynomials? The remainder will be added to the previous thing they were dividing it by. So let's try some more examples. Here I'm dividing it by a cubic divided by an x. So I'm going to put the numerator inside. X cubed plus 7x squared plus 10x minus 6, and then x plus 3. To divide these two, I want to figure out the first term. X times something is x cubed. X times x squared. Yeah. So x squared times x is x cubed. X squared times 3 is positive 3x squared. After multiplying, we subtract. These are going to cancel. 7 minus 3 is 4x squared. After subtraction, we bring down the next term. And we repeat the cycle until we run out of numbers to bring down. X times something is 4x squared. Yeah, we need to multiply the x times a 4, positive 4, and multiply it by an x. Right? X times x is x squared, and then the 1 times 4 is positive 4. So let's multiply. 4x times x is 4x squared. 4x times 3 is 12x. After multiplying, we subtract. 4 minus 4 cancels to 0. 10 minus 12 is negative 2. After subtraction, we bring down the next term. We're repeating this cycle, right, until we have nothing else to bring down. So x times something is going to give me negative 2x, right? X times negative 2. So we're going to multiply negative 2 times all the terms. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. And we subtract. These are going to cancel. And then negative times minus another negative, right? They're going to cancel, leaving us with 0 as a remainder. So I don't have to add plus 0 over x plus 3, right? This portion is not necessary because it's a remainder 0. What does it mean for it to have a remainder 0? It means that these two are factors of the original problem. When something fits perfectly into a polynomial, it means that it was a factor of that polynomial. You know, because it fits perfectly. Think about it this way, right? Is 2 a factor of 7? No, because 2 does not fit into 7 evenly. When you go 2, you can go up to 6 and you have a remainder 1. But does 2 go into 10? Yeah, it fits evenly into 10, so you have 0 as a remainder versus 1 as a remainder. When you have 0 as a remainder, it means that it fits perfectly as a factor of the number. So since x plus 3 fits in perfectly up here, x plus 3 is a factor of this cubic polynomial. Let's try one last one. Remember, I'm about to post this on the next video. You're going to be able to see synthetic division, and you're going to be able to see a different approach. So watch the 2 videos, select the method that works for you, and then let's go from there. So let's divide these, right? I'm going to divide the numerator will always go inside. 2x cubed minus 3x squared plus 4x plus 5. Divide that by x plus 2. We're going to first look at the first term. We're going to multiply it times 2x squared, right? 2 times a 1 is 2x, is 2. And then x squared times x is x cubed. So we're going to multiply this by both terms. Times the first term is 2x cubed. Times the second term, 2 times 2 is 4, is positive 4x squared. And when you subtract, these cancel. Negative 3 minus 4 turns into negative 7. And then we bring down the next term. Right? Multiply, subtract, bring down. Those 3 steps don't change. Multiply, subtract, bring down the next term. So, x times something is negative 7x squared times negative 7x. Right? So we're going to multiply. So here, multiplication. Negative 7 times 1 is negative 7. X times x is x squared. Negative 7x times 2 is negative 14x. And when we subtract, which is the next step, these cancel, but 4 minus negative 14 turns into a plus 18x. Right? 4 minus negative 14 is plus. That's how I got the 18. And then after subtraction, we bring down the next term. And since this is the last term that we're bringing down, whatever's left over is my remainder. Right? I'm done with this process. I'm done with this process whenever I finish bringing things down, all the terms down. So x times something is 18x. Positive 18. So 18 times x is 18x. 18 times 2 is 36. And we subtract. Let's cancel. 5 minus 36 is negative 31. This is my remainder. So when you're dividing the 2, you're going to get a quadratic plus the remainder. Sometimes you'll have a remainder, sometimes you won't. Now, you don't have to put plus negative. You can also just write it as a minus 31. You could also write it like this. All right, those are interchangeable. Okay, please let me know if you have any questions. Don't forget to like and subscribe, and watch the next video on synthetic division. And then you get to pick, do I prefer long division method or synthetic division? They're very similar, but one of them will require a little bit less work. Anyway, I'll calculate later.